Okay, so let's go ahead and we'll go over the module 3, topic 1, section 3. This work is due on Thursday. Let me see. Let's go ahead and do Ms. Cuevas' work. Okay, so let's go ahead and zoom in so we can see this a little bit better. Okay, there we go. Too much zoom in. Let's just go 200. 200 usually works. Okay, so I formatted a little bit, put the table on the side, just the numbers that you're going to use. Put this rectangle right here so you can type on it too. Okay, and let's go ahead and read the directions. Let's see it. So section number 3, transformation of exponential functions. So we're going to graph each transformation of g of x and write the equation for the transformed function. Okay, so what we're doing is we're going to be combining two functions. Okay, if you were going to graph both of them, f of x equals 2 to the x, and then g of x, which is just f of x plus 3, you would graph it 2 to the x, and then add 3 to each number. That would the plus 3 would actually be moving the function up. Okay, so what happens, so what I'm going to do is I'm just going to get this 2 to the x right here, and since that is equal to f of x, I'm going to plug that in for that f of x. So on the bottom, I'm going to type in the new functions. We got g of x equals, so f of x, so instead of f of x, I'm going to write down 2 to the x power. So I don't have the editor, so I'm going to put like this, x to the 2 to the x, and then plus 3. Okay, so that's going to be our new our g of x. So 2 to the x plus 3. Okay, so next thing we're going to do is we're just going to use those numbers, plug them in for x, and add 3 to it. Okay, if you already done the other sections, you should know when you have a number and you raise it to a negative exponent, it's going to turn it into a fraction. So this 2 to the x is going to become 1 over 2 to the x, which is 1 over 4. And we're going to get 1 over 4 okay. So we're going to get 1 over 4 plus 3. So 1 over 4 plus 3, that would be 3 and 1, 4. Okay. And actually, let me go ahead and just type it in. Okay. Let me just type it in. By now, you should be pretty good about doing the work. Okay, so we said 2 to the negative 2, that's gonna be 1 4. So 1 4 plus 3 would be 3 and 1 4. So it'll be 3 and 1 4. Okay, let me make this a little bit smaller so the fraction will fit there. Okay, so we try 8. Does 8 work? Nope. Let's try 6. So 3 and 1. 3 and 1 4. There we go. I can also make this a little bit bigger, a little wider. Okay, and then I can change the font. Let's see what happens if I change it to 7. That still fits. Maybe let's try 10. No, 10 gets too big. There you go. Let's try it. So 3 and 1 4. Okay, so we try negative 1. So 2 to the negative 1. That's just going to flip it. So it makes it a 1/2. So 1/2 plus 3. That will be 3 and 1/2. Okay. And then we plug in 0. So 2 to the 0 is 1. 1 plus 3 is equal to 4. Okay. And then we go 2 to the first power. 2 to the power is 2. 2 plus 3 is 5. And the next one would be 2 to the second. So 2 to the second is 4. 4 plus 3 is 7. Okay. So those will be my points. Okay, and then I'm going to graph them. Not sure about, let's see, get a curve connector. I'm not sure if you want to try those. I'm just going to go ahead and use this, and I'm just going to graph them. Okay, so I have -2 is 3 and 1/4. So 1, 2, 3. So 3 and 1/4 should be somewhere around there. Okay, and then we have -2, 3 and 1/2 right there. Okay, and then we have 0 and 4, which gives us our y-intercept right there. Okay, and then we got 1 and 5, so 1 and 5 right here. Come on, there we go. And then we got 2 and 7, so 2, there's 6, there's 7 right there. Now, the thing you've noticed with exponential functions is that the graphs, they get big really quick, okay? So if we try to put in 3, let's see, 2 to the third will be 8, 8 plus 3 will be 11. So 8, 9, 10, 11, you could try to put 11 up here out of the graph. To kind of give you a better idea what the graph's gonna look like. And then you just connect the dots. So the dots would be like this. Okay. So there's our graph. Keeps going in this direction. It's never going to cross y equals 3. So there's what's called an asymptote. It doesn't cross it, it's like a barrier. We have talked, I think, a little bit about that before. So there's our graph. Okay, so there's our graph for number 1. So same thing you're gonna do for 1, 2, let's see, 3 and 4. There is one that changes a little bit. It changes a little bit, and I'm gonna go over that. Okay, this one, same thing. You're gonna plug in the 3 to x minus 1, put it in for f of x. Same thing for this one. Make sure you follow PEMDAS. Okay, so let's take a look at the second one. Okay, this is the other one that we're going to be dealing with. So when you get to number 7, okay, it's a little bit different. It looks different than the other one. 7 and 8 looks different than the other one. Okay, in this one, what you're gonna do is you're gonna go backwards. So this, see the x minus 1? The x minus 1 is actually gonna be retaking the place of the x. Okay, so it's gonna look something like this. Okay, so it's still gonna be g of x equals, but instead of putting the 2 to the x and put it like down here, which looks like is that you would use the distributive property, but you're not. So it's just that x minus 1 is gonna replace the x value on f of x, okay? So the x minus 1 replaces what's gonna be the value of x. So we're gonna have 2, and I'm gonna use this symbol right here to the x power. Okay. Oh, replacing the x, so it'll be 2 to the x minus 1. Okay, so the x minus 1 should be on the exponent. So let me write it down also so you guys can see it. Too much. I don't want that. Okay, so it's gonna look something like this. It's gonna be 2 to the x minus 1. Okay, so this, the x minus 1 from here, you're gonna grab that and replace the x on top. So over here on number 8, same thing. You're gonna get the x plus 4, and you're gonna plug it in for that x value on top. Okay, so that's what we're gonna do. Okay, so let's go ahead and let's plug them in. Let's see what we get. So we have -2. We plug that in for our x. -2 minus 1, that's -3. The -3 on the exponent is just going to flip the number. So instead of 2, we're going to have 1 over 2 to the third. So 2 times 2 is 4, times 2 is 8. Okay. And I can type it. So we said it was going to be 1 over 8. Okay. And then we plug in -1. -1 minus 1 is -2. We got 2 to the -2 power, which is 1 over 4. And then we try 0. In this case, it's not going to be 1 because we are doing something to that 0. So we plug in 0 for x. 0 minus 1, that's going to be -1. 2 to the -1, that would just be the inverse. And that would just be 1/2. Now when we plug in 1, 1 minus 1 is 0. So now we got 2 to the 0 power. Okay, and 2 to the 0 power is just going to be 1. And then we plug in 2. So 2 minus 1 is 1. 2 to the first power will be 2. Okay, so and let's go ahead and plug those. So do that. Okay, so we have -2 to the 1/8. Now somebody was asking me, is like, how do you guesstimate where that is? Well, you just try. Okay, very, very close to there. Okay, then 1/4, a little bit higher. And then 0 is 1/2, right about there. And then 1 and 1, right about there. And then you've got 2 and 2, right about there. Okay. And let's see, it looks like we're multiplying by 2. You can figure out a few other ones. If you plug in 3, 3 minus 1 will be 2. 2 to the second will be 4. So at 3 we'll have 4. That one can fit there. Okay, and then we'll try 4. So 2 to the 4 minus 1 is 3. 2 to the third will be 8. So 4 and 8, and that's about where we're gonna go, because I think the next one will be like 16. Looks like the constant ratio that we're multiplying by is 2. So we're multiplying by 2. 1/2 times 2, 1/4 times 2, 1/8 times 2. So 2 is the number we're multiplying by. Okay, and then we're going to connect them. And again, it should look like the Superman, right? It's not dashed, it's just not coming out correctly. Okay, so those are the 2 types of problems you're gonna do. The one where you get whatever the f of x is equal to and plug it in for the f of x on the bottom, or the ones that look like g of x equals f parentheses x minus 1. You're gonna graph that and plug it in for the x on the top. If you have any questions, you know where to find me, okay? Thank you.